5.3, here we go. So last time we learned about reducing fractions. That was 5.1, and we went all the way back to pre-algebra. Remember that? So 6/8 can be reduced down to 3/4 by 2. So in algebra, now we have variables. So we learn how to reduce things. In 5.2, we learn how to multiply and divide, and then going all the way back to pre-algebra. We learned that you have to cancel off first, and then you can multiply straight across for your final answer. With algebra, it's a little bit different, because then sometimes you got to factor stuff into its prime factors or prime numbers and then cancel them. And then you can finally multiply straight across. Well, let's go with the rest of the stuff here. And as we are in chapter 5, remember this is all about wonderful things called fractions. The sophisticated name is rational functions, but it's just fractions with variables. That's about it. Alright, so today, the rest of chapter 5 here, we're going to learn how to add, subtract. Then we're going to learn something called complex fractions. If fractions are not bad enough, we're going to call them complex afterwards. And then finally, which is our goal here in algebra, is to finally, can you set up an equation and can you solve it? That's kind of really the goal of algebra in here. And then of course we have to have one final section talking about how to have some applications in this process. So let's go for it. As soon as I can do this. Okay. Alright, hopefully you printed out the match problems as well, so you don't have to rewrite the whole entire problem all the time. And try it yourself here. Again, we're going all the way back to pre-algebra. Just one little quick concept here, and then we'll jump into algebra. And again, the whole point here is to see how things are completely connected here. A little bit more complicated, but still connected. Alright, so hopefully we know this here from pre-algebra. If you have a common denominator, you keep that denominator. So it is going to be an 8 over here. And then what we do is we add or subtract only the numerators. So 3 plus 1 is 4. And then the question is, can I reduce? Going all the way back to 5.1. Does 4/8 reduce? Absolutely. Eventually you want a number of, or an answer of 1/2. It is technically wrong to leave it as 4/8. Because that is not fraction in its reduced form. So the same thing is going to happen here. So for number 2, do we have common denominators? We sure do. Well, just another little spiel here. What's really happening here? Just so we know, if you take numbers into their prime numbers, or factor them down into its prime numbers, that's how you get the 1/2. That's kind of the process we're going to be doing in algebra. Okay, let's go for it here. So common denominator now is x squared minus 9. On top, we're trying to add the x and 3 together, not like terms, so therefore we're going to write them separately. But still, I have a single numerator, right? X plus 3. So now the question is, does this still reduce? Yeah. One extra little step, this little step right here that we had to do, we have to change it to sort of prime numbers or prime factors. The x plus 3 stays the same, but x squared minus 9, I think you guys should be able to factor that. So difference of 2 squares, so that means one is going to be the x plus 3, the other one's going to be x minus 3. And just like problem number 1, we cancel off any factors that are exactly the same top and bottom, and how about 1 over x minus 3 as our final answer? Alright, let's jump to subtraction. See how subtraction works. and I personally don't like subtraction. I would rather change it to addition, and then I would do the same thing like I did for number 2. So change that to addition right here. The only thing I got to change then is the signs on the numerator. So that becomes a negative x, that becomes a positive 3 this time. So at that point I can just sort of be adding in my head as opposed to subtracting. So 2x. Adding a negative x would give us just an x. Negative 5 and a positive 3. Negative 2. I'll go with that. Hey, that's kind of funny. So the number on top and the number on the bottom is exactly or are exactly the same. That means they are common factors, so I can cancel both of them out. Anybody with the final answer? Just one. That means one whole piece. Alright, what happens if we don't have common denominators initially? Well, that means we have to make those common denominators then. Alright, and you don't necessarily always want to just multiply the 10 and the 42. You want to see if you can sort of get a number in common. Alright, and there's kind of different ways to do it. Especially working with big numbers. The best way to do this is to multiply the 42 and the 10 first off to the side and think about what do they have in common. What's a factor they have in common? Not 5, because the 42, 5 can't go into 42.
2.
Yeah, 2, right? Doesn't a 10 and a 42 have a 2 in common? If that is the case, I can divide this guy by 2 and this would be the common denominator. And again, this is when you're working with big numbers. Smaller numbers, I think you guys know what to do. So multiply the numbers together and then divide out the common factors. Okay, so what should I multiply? Multiply 10 by what to give me? 21 is good, yeah. So if I multiply on the bottom, I got to multiply on top. 21 times 3. I heard 63. I'll go with it. And then 42 times what gives you 210? 5, I agree. And all yours to finish off. Alright, hopefully you got a 218 on top, or so 118 on top. And the only question is, can I reduce this down some more? Yep, see a few nods there, okay. At least by 2, right, because they're both even numbers. So dividing 118 by 2 gives me a 59. 210 by 2 gives me a 105, and the question is, can I reduce that some more or no? No. Heard a no, so I'm good to go. Okay, 59 over 105, final answer. Again, same exact process we're going to use here, now with variables. So let's start off slowly again. For these examples here, it's just sort of one of each type here that we get. These practice problems, I guess, or example problems in the lecture, they are very, very similar to the example problems in the textbook. So if you want to see another way or another example of number 5 where we're adding this type of problem here together, example problem number 5 in your textbook is going to be very, 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 very similar. Cool, so you sort of get a second look. If you still sort of don't get that, remember on Math TV there's videos. So they'll do the example problem in the textbook as a video. So I sort of have 3 different ways to sort of see a very similar problem. Okay, so let's go for it here. Now we got variables. This is the tough part here. What we have to do is we have to factor it down first because I need to know what common factors they have. So -3 stays, but I need 2 numbers multiplied to -8, add to -2. Awesome, -4 and 2. Going over here, 4 on top, and difference of 2 squares, so x plus 4, x minus 4. Alright, so let's go for it here. So what we're trying to do is we're trying to do, in a sense, do what we did with the last problem here. We're trying to get a common denominator, which is we can multiply through, but we have to get rid of the ones that are the same in both of them. Okay, so whatever we have that's the same both, we're just going to write down once. That's kind of where we're at here. So really what's happening is we need the x minus 4 from the first fraction. We need the x plus 2 from the first fraction. As we go over here, we just looked for any new factors. So I need the x plus 4. Alright, and again, I would write down the x minus 4, but I already have one over here, so I don't need to write it down twice. It's almost like, remember how we divided 420 by 2, right? We took out that common factor. But in this case, instead of taking it out, we just don't write it down. And there's your common factor. So going back the other way then, so this common denominator should be written over here as well. Let me do that again just to make sure we got it. Those of you that are staring at the screen. So we need to write down each of these factors, but we have to take out the ones that are the same in both. And so instead of multiplying everything through and then sort of scratching things out, what we do is we just sort of write down the factors as they go in, and we don't write down any doubles. This one's going to come down here, and this one we don't have to write down because I already have it over here. And there's my common denominator. Alright, whatever is the denominator here better also be the denominator here. These are probably like the longest problems in the textbook. Right here, 5.3. So now let's go back through it here. So what's my multiplier to get my common denominator? Well, I have the x minus 4, I have the x plus 2. My new one for my first fraction is the x plus 4. So it wasn't here, now it's here, therefore I'm going to multiply the numerator by this x plus 4, by this new factor. Alright, -3 times x, -3x, and -3 times 4 makes minus 12. Going over here, let's see, I got the x plus 4s here, I got the x minus 4s here. The new one is the x plus 2. So therefore, there's my x plus 2. Okay, before we move on though, I just want to show you where that's coming from. The reason why we multiply the x plus 4 here is to make the numerator and denominator the same, right? So technically what I am really doing also, I'm doing this right here, right? I'm multiplying this, so it's the same exact thing as this denominator. And whatever I multiply on the bottom, I also have to multiply on top, right? Technically I'm multiplying by 1. So same thing over here. For the second fraction here, what allows me to multiply the x plus 2 is technically I'm multiplying an x plus 2 on the bottom as well. So therefore it's going to look, this fraction now is looking the same as this fraction. Okay, once we got that in place, let's put down the common denominator. X x minus 4. Let's see, x plus 2, x plus 4. Doesn't matter the order of them as long as all of them are there. Negative 3x plus 4x makes x. And let's see what this is. Negative 12 and 8. Hey, got something here. I have a common factor that's both on top and bottom right here. So does it always happen? No. Does it sometimes happen? Yes. So we have to get rid of this guy and this guy. Those are common terms. So how about a final answer? 1 is on top, and we'll have ourselves x plus 2 multiplying x plus 4. Not all yours. Number 6, see if you can go beginning to end based upon problem number 5. So I have to factor down the denominators first before I can do anything else here, so let's rewrite everything all over again. But now in factored form of my denominator, so I can factor a 2 here. Leftover is x minus 3. Numerator stays the same, no change yet, because I haven't started to put the common denominator yet together. And I got x squared minus 9. I think we've seen that before already. X plus 3x minus 3 is perfect. Again with a 3 on top because we haven't put down a common denominator yet. Alright, so here we go. The tough part. Let's see. From this one I need a 2. This little coefficient of 2. That is also a factor. 2 goes down. X minus 3 goes down for my first fraction. Alright, looking at my second fraction, the only new stuff is this x plus 3. So x plus 3 goes down. I already have the x minus 3, so I don't need to write it down again. So there is my common denominator. Alright, so there better be the common denominator on the other side as well. Alright, now this one kind of depends how much detail you want here. If you write down, so the 2 is I got x minus 3, I got the new one is the x plus 3, so technically what I'm really doing is I'm multiplying the denominator by x plus 3, I'm multiplying also the numerator by x plus 3. Alright, can you guys do this in your head right here? Of course you can. You're sophisticated Math 63 students. X times x is x squared. Let's see, x times 3, that would be a 3x minus 4x. So technically that's just going to be a minus x there. And negative 4 of 3 minus 12 is good. Going over here, x plus 3 is here. X minus 3 is here. The new portion is this 2. So technically I need a new factor of 2 here. Therefore I'm going to multiply the top by 2 or a 6. Alright, can you finish it off from there? Alright, so let me put down the common denominator again. And then let me put the numerators together. So x squared. X is here, so minus 12 plus 6 would just be a minus 6. And I guess the only question is if the numerator can be factored, and if it can be factored, can it reduce any of the factors on the bottom? So again, rewriting the common denominator, but two numbers, multiply negative 6, add to negative 2. Negative 3 and 2, I like that. And yes, we do have a common factor, x minus 3. There it is. So how about cancel x minus 3, final answer. Also notice that on top, right here, I do have parentheses around the x plus 2. For my final answer, I really don't need parentheses because it's only one single polynomial called x plus 2. So no need to put parentheses here since there's no multiplication between any other polynomial. On the bottom, I got 2 times x plus 3. And of course, show of hands, somebody got that before I did. 1, 2, 3, 4. All right, got some work ahead of us here on that one. And of course, the honesty question. Raise your hand if you could honestly say, Mr. H, I read 5-3, 5-4, 5-5. We got a donut today. All right. Oh, 1. Okay. Got. Oh, question. Okay.
How did you get x plus 3 and x minus 1 and x plus 2?
Say the question again. Yeah.
Like, did you just forget about like the 6 on the right side? You just factored out the x2 minus x minus 6.
Question is, how did I go from here to here?
Yeah.
Oh, this is just factoring a trinomial. So it's we get 2 numbers that multiply to -3, but we add up to -1. So let me go to something like this. I think sometimes you guys may have learned it by this little Xbox method. You take the -6, put it on top. Take the -1, put it on the bottom, and the question is, what numbers would multiply? I'll pull a dot for multiply to -6, but if you add them together, it gives you -1. And that number those numbers would be a -3 and 2. So then that -3 becomes that -3. Positive 2 becomes this little +2. All right, good question there. Mm-hmm.
Okay, so I know how you factor that out, but it's x squared minus x minus 12. You just factor that out, like, to x squared minus x minus 6.
No. Yeah, the question is, how did this become this?
Yeah.
Sure, we're just adding or subtracting numerators, just exactly what it says. So we are just working out this part right here. So the x squared stays because there's nothing to add it with. The minus x stays because there's nothing to add it with, but a -12 plus a +6 makes a -6. Mm-hmm. All right, a little bit more sophisticated. I think you guys can still handle it here. Give you guys maybe like a 30-second head start, and then we'll do it together. All right, those waiting for me, let's go for it together. So looking at this problem here, yes, you do have to factor these denominators down to their prime factors as much as you can. So 2 numbers multiplied to 4, add to 5. I'll go with that, 4 and 1. The 2x minus 4 stays the same, no changes there. And again, for this one, factoring it down, 2 numbers multiplied to 8, add to 6. 4 and 2, I agree. And x minus 4 stays on top. If you got to that step, you're doing good. So now let's start writing down our common denominator here. So I need an x plus 1 for my first fraction here. I need an x plus 4 for my first fraction. Going over here, there's my redundancy right here. The x plus 4, I already have it, so no need to write it down again. So therefore, the new one is x plus 2. And done. There's my common denominator.
Question.
Mm-hmm.
Why can't you factor the top like the 2x minus 4?
Question came up is, why don't we factor the 2x minus 4? Why doesn't we put a 2 here and then x minus 2? It's because we're going to be multiplying this with another one, so we're going to be foiling this out anyways. So it makes no sense to factor down when we're going to be multiplying it out anyway. So you would only factor out denominators only. And the reason for it is because you're just trying to find that common denominator. So another good question. It's 2 good questions today. All right. You guys are awake. This is good. Well, no, hold on. 2 people are awake. This is good. At least 2 people are awake. Okay, common denominator I got. So now let's see. X plus 1 is here. X plus 4 is here. The new stuff is x plus 2. Therefore, I'm multiplying the top by x plus 2. All right, sophisticated Math 63 students, let's go. 2x times x is 2x squared. Easy enough. Let's see if we can do the middle here. 2x times 2. 4x. And then the other middle term is a negative 4x. Hey, that's kind of weird. 4x and then minus 4x. Those will cancel each other out. So no middle term here. The end term is negative 4 times 2 is a negative 8. So just a binomial. Alright, going on this one. X minus 1 is the new term. So therefore multiply the top by x. So x plus 1. Alright, x times x is x squared. That's easy enough. X times 1 is x. Subtract 4x makes minus 3x. And negative 4 times 1 is negative 4 minus 4. Alright, so in this case, if you feel comfortable subtraction, that's fine by me. I don't like it just because I'd rather just add and subtract. So I'm going to change it to a plus. I'm going to change all the signs on my second numerator. So negative x squared now, a positive 3x, and a positive 4. So rewriting denominator again. Whew. All right, let's see, 2x squared and a negative x squared makes just an x squared. Nothing to add together, so just this little 3x just comes down, so positive 3x. And negative 8 and a positive 4. Makes a minus 4. And let's see, can I factor this one? Let's see, two numbers multiply negative 4, add to positive 3. Alright, 4 negative 1. Totally agree there as well. So let's see, x plus 4, x minus 1. And I think we're almost done. So x plus 4's are gone. Those are common factors. X minus 1 on top. And again, I want you guys to notice why I dropped the parenthesis on top, why I had to keep the parentheses on the bottom. Right? Because on top I still have... Got it. Just a second. The parentheses, I don't have to put any parentheses here because I just have a single polynomial, right? Just x minus 1. There's no multiplication. The parentheses I still have to keep here. Okay, and the question is, Mr. H, why do you change the sign to an addition problem? Just because I like to. Just because addition is a lot easier to think about than subtraction. So if I just change this to addition, change the signs here, a lot easier for me to think about it. Let me do a
It's all the second.
So again?
The second section of the problem, all the signs.
Yep. Let me give you an example here real quick here. So how about 12 subtract 58? What we do here is we change this guy to a plus. And we do that. And at least a little bit easier to think about how we're going to do that problem. Same thing here. We change the subtraction to addition, and then we change the sign on our numerator. Cool. All right, and then just one more just to clarify here. How about it feels like this? Right, that's a little more complicated to think about as opposed to if I change this to a plus, and I would say, oh, that's pretty easy. That's going to be 60. So that's the reason. All right, number 8. This one's a little bit, there's like a little short sort of cut or a little funny thing right over here. So let's talk about the funny thing as soon as you guys write it down. All right, we have seen this before when we were reducing fractions in 5.1. Notice I have an x minus 4. This one's a 4 minus x. Hey, aren't those common denominators, except they're just sort of opposites of each other, aren't they? So kind of like this, if you think about b minus a, remember thinking back from 5.1 here, isn't that the same thing as a minus b with a negative in front of it? That's how we think of it as opposites. Those of you that did your 5.1 homework had practice with it. Right, if you just change these around, if you want the a to go in front and the b to go to the back, which you've in a sense done with subtraction, you have made it an opposite. So notice the a is positive, therefore I have to put a negative on the outside, so therefore if I multiply in, there's my negative a, and I multiply in, there's my positive b. So it stays the same. So here's what we do. Keep things the same, plus sign here, x plus 12, and the only change occurs is with that 4 minus x. We're going to change that to a negative of a x minus 4. So we switch the numbers around. It's kind of like there is a common denominator, but it's in disguise. Or I should say like in disguise. Just a little reference to something. Okay. Now let's talk about fractions here for a little bit. Remember with negatives, I really don't like keeping negatives on the bottom. I either like to put the negatives on top, and if I do, then this changes to a negative x and a negative 12 because it's a multiplier. Or I put the negative out in front. But let's do a little short, so we have to write it down twice here. If I put the negative in front, what's the operation called if I'm adding a negative? Adding a negative, same thing as subtraction, isn't it? So if I do, let's do two things here. So mentally what we do is we put this little negative out in front, right here. Then we understand that we're adding a negative, therefore we're going to be subtraction. This is going to be a subtraction problem on our hand. So x squared x minus 4. That is now a subtraction problem of x plus 12 over x minus 4. Alright, question arises, of course, is Mr. H, what happens if we were subtracting? So what's subtracting a negative? Adding, so then this would have been a plus sign. We good? So really that little negative just changes the operation around. Alright. Alright, let's keep it a subtraction for those of you that want to keep it a subtraction. Common denominator is x minus 4. So let's looks like x squared subtract, hey, nothing, huh? There's no x squared here, so it's just going to be x squared. So what's nothing subtract x? Okay, negative x. What's nothing subtract 12? Okay, minus 12 or negative 12, yep, and all yours to finish off the problem. Alright, hopefully you realize the top can be factored. See, two numbers multiplied, negative 12 add to negative 1 would then be a negative 4 and positive 3. And the x minus 4s are gone. They cancel each other out, so therefore final answer is just x plus 3. Alright, how about if we, number 9, the whole concept here is what happens if we add a whole number with a fraction. What do we do here? Alright, can we change any integer into a fraction? Absolutely, yeah, just put a little 1 there. But in terms of common denominators, though, that's even easier. What is our common denominator? That's 5x minus 1, right? So all we get to write down is we get to write down to 5x minus 1 right away as our common denominator. And since this is just a plain old 1 right over here, that means our whole multiplier would be 5x minus 1. Alright, so 2 times 5x minus 1 gives you 10x minus 2. The other one, since we did not change anything on our denominator at all, that means that 25 does not change at all either, so it's just 25. Cool. All right, common denominator is 5x minus 1. Let's see on top, it's a 10x, looks like plus 23. All right, and does that change? Is that nothing, huh? Does not factor, nothing factors, nothing reduces, so that would be the final answer then. Alright, and of course, got to add a little word problem to this all. Somewhat of an easy one here now. Alright, and let's set this up here. We're trying to figure out, let's see, one number is 3 times another. So since we're talking about numbers here, x then would be, I think we've seen this before. You can write one number, you can write the first number. And again, since we're just talking numbers, it doesn't matter which one's the one number, which one's the other. Because at the end we're going to say the numbers are this and this. So we don't have to sort of really see the exact correlation between one number and another number. You could write one number, you could say first number, maybe first number would be better so it doesn't equate back into the word problem itself. Okay, but it says one number is 3 times another. One number is 3 times. So the first number is x. What would the second number going to be? X. Since we know the relationship between one and the other, are we okay with a 3x? Got it. Question is, why wouldn't it be a 3y? Is because we have a relationship between one and the other. So if it says one number is, that little is part just created the relationship. Okay, it says write an expression for the sum of the reciprocals of the two numbers. Whoa, okay, hold on. Then simplify that expression. Write an expression for the sum of the reciprocal. Okay, what's the reciprocal of x? 1 over x. What's the reciprocal of 3x? Cool, okay, and then we've got to write the sum of this. So how about reciprocal of x is 1 over x. It's the sum, and it's the reciprocal of 3x. So how about 1 over 3x? All right, at that point now we can see if we can reduce that or simplify it. It should be an easy one here. What's the common denominator? 1. 1 over x. 1 over x. What's the reciprocal of x? 1 over x. 1 over x. What's the reciprocal of 3x? 3x. 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 3 Hey, 3x. All right, 3x over here, 3x over here. So the first fraction needs to be multiplied by 3. Second fraction stays the same and has the common denominator of 3x on the bottom with a 4 on top. 3 plus 1 is a 4. And there's my final answer. All right. Now going to 5.4, something called the complex fraction. So if fractions are not bad enough, now we call them complex. Let's see what's happening here. Alright, well, so what does it mean to be a complex fraction? First of all, it means that you have a fraction within another fraction. So this is example 1 from the textbook. I figured this would be a good way to sort of show the two things here. So you have 3/4, and it is being divided by 5/8. So you have a fraction that's technically inside another fraction. How do we solve this? Well, there's two different methods to actually simplify this. The first method, and probably the faster method, I'll probably say this here, it's used whenever the denominator is a pretty easy denominator. Sometimes it's called a monomial, if you're just multiplying by 8 or multiplying by. So notice 3/4 divided by 5/8. Notice both of these fractions have a common denominator of 8. So what we do, we multiply by the common denominator of both top and bottom. And what this does, it gets to reduce down each of the denominators. So 4 goes in 8 twice, and 2 times 3 is 6. 8 goes in 8 once, so those cancel off completely, and then you got the 5. So notice I've canceled off the common denominators, and now I've made it into a simple fraction. So that's one way to do it. On the easier problems, that's the general way we do it. On the more sophisticated problems, here's what we do. We convert this, instead of a division problem, we change it into a multiplication problem. So notice the 3/4 stays. 3/4 stays the same. Instead of dividing by 5/8, we're going to be multiplying by the reciprocal, or 8/5. And once you get to this step, hey, that becomes an easier problem here. We can multiply them through them together, or you can reduce down the fraction. 4 and 8 could be reduced right away if you like. That would have been a 2. Eventually you still get 6/5 both ways. Are we good there? That was a good old pre-algebra problem. Alright, we're going to favor method number 1. And if it just looks really, really complicated as a problem, we're going to jump to method number 2. That's the usual method here. So 2/3 being divided by 5/6. What should we multiply both top and bottom by? A by 6 would do it. So how about this here? Multiply this by 6, multiply this by 6, whichever way you write it. You put a little dot if you like. And any which way, this 3 goes to a 1, this goes to a 2, so how about 2 times 2 is 4. The 6 is canceled completely, and how about I get myself a 4/5. Okay, I want to show it to you really the other way as well, just to make sure it works here. So 2/3, 2/3 is here. Now we're going to be multiplying by, instead of 5/6, it's going to be a 6/5. So there's the other method. This is method number 2. And so notice that becomes a 1, that becomes a 2, and we get ourselves, hey, same thing both ways, doesn't matter. Method number 1 looks a little tiny bit easier, right? Just a little bit faster. So we'll go with that. Okay, of course we have to get more sophisticated here. So how about adding in some variables here? So 1 over x minus 1/3, all being divided by 1 over x plus 1/3. All right, I'm going to try this by method 1. You don't have to do it by both methods, just by one of them. So this is easy enough problem here. Notice the denominators. There's a x, there's a 3, there's a x, there's a 3. What's my common denominator? 3x. All right, so let's multiply the top by 3x. Let's multiply the bottom by 3x. Except in this case, we've got to think about almost like, in a sense, distributing the 3x. So as the 3x goes over here, what's going to cancel? As the 3x multiplies in here, I heard the x will cancel. Is that right? Because there's x on the bottom. So everybody okay? We're just left with a 3 then. Let me finish it off. See if this makes sense here. Minus sign goes down. Minus sign goes here. Now, as the 3x multiplies into this other one here, what's going to cancel now? Yeah, 3's obviously right because you got 3 as a denominator. So what's left over? Just the x. Are we good there?
Why isn't it 1 over negative x? Negative 1 over x.
Say again. For the first one?
Yeah. Because I wrote everything online and there was still a 1 above because we just canceled a 3. And since it was like a negative 1/3, and since we canceled a 3, will it still be wrong if it was still in like 1 over x?
1 over x. Let's try. Let's see. Let me add a little more detail here. As the 3x multiplies in here, into the first one, it's going to be 1 times 3x or 3x?
I'm talking about the second part.
Okay, got it. Okay, so this becomes a 3. As it multiplies into here, let's get 1/3 multiplying 3x, which eventually gets you 3x over 3. The 3's are gone, so you're just left with that x that was on top.
Okay, no worries.
The 3 stays there. All right, let's multiply the 3x into your denominator. So 3x times 1 over x. X's are gone. We're left with 3 is good. Plus sign this time. 3 multiplies into the 1/3. What cancels? 3's cancel. What am I left with? All right, that's cool. Now the only question I have is, do these two reduce? All right, we got about 3 people shaking yes and a few people shaking no. Got to decide on this here. Is this the same exact factor as this? Are these two exactly identical? No, they're not. One has a minus, one has a plus. Therefore, these will not cancel each other out. So that would be the final answer. It looks kind of weird because we normally would like the variable in front than the number in the back. But it stays. I guess you can if you really, really wanted to. Remember this one right here? The x can go in front. The denominator can be changed, right, without changing anything at all. The numerator, if you wanted to put the x in front, the 3 in the back, then what we'll do is we'll put a little minus in front of the fraction. And that's okay. That would be the same. Again, they still can't reduce. They still can't cancel. Okay, so notice I was still able to do method number 1 because technically you got the 3, the x, the 3, the x. This was still a monomial. If you're multiplying through by a monomial, you're still doing good. Number 3, on the other hand, that's when things get a little bit more complicated. And so in this case, for number 3, we are going to go back to and think about method number 2, because I don't want to be multiplying by a binomial. Once you start multiplying by binomials, you got a lot more multiplication to do than you really wanted to. Alright, so let's do this here. So let's change this into a multiplication problem then. So x plus 5 over x squared minus 16 is being multiplied by x minus 4 over x squared minus 25. Alright, now let's, hey, this is 5.2 then, is that right? This is 5.2? Things we covered the other day. I'm going to factor everything down as much as possible, cancel like terms top and bottom, and then leave the rest or multiply the rest together. So x plus 5 over x plus 4, x minus 4. X minus 4 on top of that one, and x squared minus 25 would be x plus 5, x minus 5. And now you can see which are the like terms you want to get rid of. X minus 4s are gone, the x plus 5s are gone, but so final answer, how about 1 on top? It's a unit fraction. I get x plus 4, x minus 5. And again, if one method you're sort of getting stuck and you're not getting to where you want to go, just switch to the other method. That might be a little easier. But the rule of thumb is if you are multiplying by a monomial, either by a number or a number in a variable, do method number 1. If you need to multiply it through by a binomial or a trinomial, at that point then you just switch to method number 2. Okay, number 4. Alright, this one, or looking at this one here. I would multiply through by a monomial. So what is that monomial that I would like to multiply by? Whoa, just kidding. Okay. So looking at my denominators, I have an x squared over here. I have an x, and then I have another x squared. I think I'll multiply by x squared. So let's multiply this top by x squared, the bottom by x squared. Let's see where we're at. So x squared, hey, this is funny. X squared times 1. Just going to be x squared, is that right? There's nothing to cancel with. As the x squared multiplies into the second term, the x squareds cancel completely. Everybody okay with just a minus 9 then? All right, on the bottom there, x squared times 1, again, just going to leave this as x squared. Minus sign comes down, all right? Okay, let's see if we can think about this here as we go. X squared times 1 over x. Yeah, x, because one of the x's will cancel from the x squared, but you're still left with another one, so 1 times x is just x. All right, minus, and then 6 over x squared. Just the 6. The x squareds cancel completely. Now the question for you guys, can you factor it and reduce some more? Hopefully already done here. So the top can be factored into two binomials, x plus 3x minus 3. On the bottom, two numbers multiplied in negative 6 add to negative 1. I'll go with that. Negative 3, positive 2. And the x minus 3's will cancel as common factors. And final answer, x plus 3 over x plus 2. All right, and the final problem for this section. This one sort of incorporates two things at once. Notice the little 2 on the outside is just being added to. So 2 is not the complex fraction. It's this one right here that's the complex fraction right here. So we sort of put it into an expression now. How do we simplify this first, and then we're going to add 2 later? So in this case, just concentrate on this fraction alone. Notice the 5 is not a complex fraction. That's fine right there. It's this bottom one here. So what's my denominator for the bottom only? It's 5, right? So how about this? Let's multiply top and bottom by 5. So leaving the 2 alone. 2 is sort of separate for now. Alright, 5 times 5 on top, that's easy, but the 2 stands in front, 2 plus, or whatever this is going to end up being here. So 5 times 5 is 25 to the top. Let's see, 5 times x, that's 5x, and then 5 times a minus 1/5, just a 1, is that right? Anybody remember doing a problem sort of similar? Maybe like number 9 from the last section or some weird stuff like that? Alright, so now to put this together. Now I'm going to go back to 5.2 or 5.3. Yeah, 5.3. Thinking about how to add and subtract, we need a common denominator now, which is a 1 underneath the 2, and then as the common number would be 5x minus 1. Need to multiply the 2 by that 5x minus 1. Okay, finishing it off, I think we had a problem very similar a little while ago on that. Keeping that common denominator is 5x minus 1. Adding the numerators, 10x plus nothing is still 10x. And negative 2 plus 25 is a minus 23, or plus 23. Nothing reduces, nothing factors, so therefore we're done there. You know, just there's two homework problems that are still a little bit different than the ones that we've looked at already. So let's go just a little bit more. Let's go two more problems on this section. We've got to check these out because these ones, again, they tend to be just a little bit different. So number 45 off the homework, it looks like this. And again, I'd rather give you a complete picture than sort of not enough. Okay, this one. So the rule of thumb is that if you're trying to multiply by a binomial, maybe a better thing to do is just, again, these are the more complicated problems as well.
That's b plus 5?
That's number 45, and it's b plus 5. Yeah, these are all b minus 1, b minus 1. All right, so notice you got a b minus 1 and you got a b plus 5. Those tend to be the common denominators. They are binomials, right? But if I were to change this into a multiplication problem, here's my problem. This guy is still not just a single fraction. I'd have to simplify this still some more. We good? So I'm gonna try this here. We're gonna try it by multiplying through with a common denominator. So in this case, 5 does not have a common denominator. So b minus 1, and this will be plus 5. That would be the common denominator. So we're multiplying by two binomials. Oof. That was bad multiplying by one binomial. Okay, yes, they do get a little lengthy here as we do them. Alright, so let's go for it here. B minus 1 times b plus 5 is multiplying 5. There's that one. And that's going to be not so fun. So here, how about this? We just make one big giant fraction. And we're going to write down each of these here. So 5 is multiplying b minus 1 with a b plus 5. Alright, plus sign. And now this multiplication. What's going to cancel? Yeah, the b minus 1s will cancel. So therefore we're left with a 4 multiplying b plus 5. And the top is done. That's good. Okay, let's go down to the bottom now. So b minus 1 times b plus 5 is multiplying 7 over b plus 5. Alright, b plus 5's cancel. So tell me if you guys agree, it's really technically 7 times b minus 1. Minus sign. Perfect. Yeah, b minus 1's cancel for the second multiplication here. So it's 3 times b plus 5. Alright, all yours to simplify as much as you can. Go for it. I'll give you guys the answer here, so once you're done, just kind of look up at the answer to see if you guys got the same thing I did. So multiply all that out and just sort of see. All right, let me try this here. So b minus 1 times b plus 5, what I did is I did it over here to the side. I multiplied just the two binomials, so b times b is b squared. B times 5 is 5b, subtracted b makes 4b. And negative 1 times 5 is negative 5. And then I still have to multiply it by this 5 here. So 5 times b squared gives you this little 5b squared. There's my 20b. And there's my negative 25, or subtract 25. Okay, the rest I think is easy. It's just this part right here. That was the toughie. Distributing the 4 gives you the 4b plus 20. On the bottom, distributing the 7. And careful here, this little negative goes with the 3. So negative 3 times b is negative 3b. Negative 3 times 5 gives you a minus 15. Question?
Why can't they just cancel each other out in that second to last step? The b minus 1s and the b minus 5. Or the b plus 5s.
Yeah,
Top
I did
and bottom.
that too.
Yeah, right there.
All right, so let's put everything together that we know. So 5b squared on top. How about a plus 24b? How about a minus 5? On the bottom, I have, let's see, 7b plus minus 3b makes 4b. And negative 7 minus 15 minus 22. So again, still pluses and minuses, keeping things together. All right, let's show one more step here. I think we should do this one here. Let me rewrite this problem here on the bottom since I'm running out of room. Let's see if we can factor this down here. So let's see, 5b squared. The only way to get 5b squared is 5b times b. And just out of wonder here, could I multiply to get negative 25 in the middle terms, add to give me a net positive 24? I won't kill you with the math here. Ready? It's a minus 1 and a plus 5 in that order. So notice it's a negative 5 at the end through multiplication, but this is a positive 25b, subtract a b, which makes 24b. Hey, it does factor down. On the bottom, let's see, 22 and 4. I can factor out a 2. 2 goes on the outside. How about a 2b minus 11? All right. Notice we did factor, but there's nothing that cancels. There's no cancellation done from either of the sides. So the answer is either the blue one or the red one. It doesn't matter which one it is. You can put a little or if you like over here. You can put an or instead of an equal sign. If you are to factor but nothing cancels, some mathematicians say this would actually be the simplified answer because I can kind of see whether you need to cancel or not. This would be more of the simplified answer. Some mathematicians say, well, that's not the simplified answer because look, you're looking at multiplication everywhere. So the blue one is the simplified answer. Good there? And then, you know, if they really, really disagree, then they start, you know, arm wrestling to see who's going to win. And then whoever wins the arm wrestling, that's the one that's the simplified answer. No, it doesn't matter which one you. Some textbooks say this would be it. Some textbooks say this would be it. It doesn't matter. Now, if something were to cancel, let's say this was 5b minus 1, this was also 5b minus 1, then yes, you would have to cancel this to give me the final answer at the end. We good? So if you factor but nothing cancels, either or is fine. Question?
So on the test, like since we're out there, would it be the blue one or the red one?
Ha, I'm not going to tell you. The question came up on the exam itself. Which one is the answer that you prefer? I'm not going to tell you. This one gives you more information because this one tells me that you went a little further just to check whether things cancel or not, right? This one sort of, for me, this would be me personally, not on the test, because I'm not going to tell you. This one actually is a more simplified answer because it tells you with the extra step.
You kind of have to go to that step just to see if you can cancel anything out.
Yeah, yeah. You're gonna have to go to this step anyways, just to check if anything cancels anyway. So it's almost like a necessity anyways. Okay. Next one is 47 on the homework here. This is what it looks like. Again, it's a little more complicated than the practice problems were, or the matched problems were. So we should take a look at this here. Alright, so before we do anything, we got another problem. We got this whole problem of x squared minus x minus 6. We don't even know what to multiply by because this is not in factored form. The other problem is this right here. Remember, if I change this to a multiplication problem, I would have to still deal with this right here. I would still have to simplify this. That's why 45 and 47 are a little different. So the next sophisticated issue is that I get an extra step to simplify this first. So, or to factor this first. So everything else remains the same, 3 on top, but two numbers multiply -6 add to -1. Too easy, I understand. Okay. So 2 over here, x plus 2 minus 4 over x minus 3. Alright, now since we got to this step, now we can think about what should we multiply by. So what should we multiply by? X, yep, x plus 2, x minus 3, or x minus 3, x plus 2, it doesn't matter. Either or is fine. So x minus 3 times x plus 2 multiplies the top. Hey, that's kind of cool. Isn't everything going to cancel? Everything cancels. We're just left with 3 only. On the bottom, x plus 2's cancel, so we're left with 2 multiplying x minus 3 with the minus sign this time. And then the last multiplication here, finally multiplying that, gives you x minus 3's canceling, gives you 4 times x plus 2. Alright, and your job now is to simplify it a little further here. Alright, totally, I understand. It looks like it's all dry, isn't it? All this stuff. This is probably the driest chapter, I think, chapter 5. Where it's just rules and rules and rules and rules. That's it. And in 5.6, at least there's a little bit. We look at some application questions to these, but really, it's interesting. When I was studying math, it wasn't, again, second semester calculus, where you see the top of the pyramid, and you're like, wow, that's why I was doing all this stuff. Especially when you get into application questions in second semester calculus, then all this stuff sort of comes together as one big connected piece. That's all. Alright, so we finished it off already here. Let me rewrite it. Distributing the 2 on the bottom gives you 2x minus 6. Distributing the negative 4 gives you negative 4x minus 8. Combining like terms, how about a negative 2x minus 14. And let's see, how about if we multiply out a negative 2 out of that, or factor out a negative 2, leaving us x plus 7. Cool, and I say this would be a good final answer. And again, textbooks would keep that as the final answer. Some textbooks would have you multiply out that 2 to give you 2x plus 14 on the bottom. Either or, you should be familiar with both. You should say, oh, it's either that one, that one.